What's up, Chem peeps? Let's do a little photoelectron spectroscopy practice. The photoelectron spectrum of an element is shown above. Answer the following. Label the peaks with their corresponding orbital sublevel. Alright, when I do this, realize that the height of the peak represents the relative number of electrons, and the position of the peak represents the relative amount of energy required to remove those electrons. So I check out my scale here, I notice that it requires the most energy to remove electrons here, and the least amount of energy to remove electrons here. Now, think about your electron configurations. This initial peak then that requires the most energy to remove is going to be my 1s2 peak. This following peak requires less energy, quite a bit less energy, but the same number of electrons are contained here. This represents my 2s2 peak. And it makes sense that's going to take less energy because now we're in an energy level that's further away from the nucleus. After 2s2 comes 2p6. Now it requires a little less energy to remove than the 2s electrons because remember the p orbitals do not penetrate the nuclear region as well. And notice there are 6 electrons here because it's 3 times the height of my s sublevel peaks. After 2p6 comes 3s2. Again, recognize that it's only going to hold 2 electrons and matches the height of my 1s and 2s peaks, but requires far less energy because now we're in an energy level that's further from the nucleus. And this final peak would represent 3p5. It's only 2.5 times the height of my s sublevel peaks. Boom, labeled. Identify the element represented by the photoelectron spectrum. Well, which element has the electron configuration 1s2, 2s2, 2p6, 3s2, 3p5? Oh, periodic table, my very best friend. 1s2, 2s2, 2p6, 3s2, 3p5. Chlorine is our winner. Element identified. Boom. Which electrons would be the first electrons to be removed? It's going to be those electrons that are furthest from the nucleus, the ones that require the least amount of energy. In this case, it's going to be the 3p electrons. Boom. Which electrons will be the last electrons to be removed? They're going to be the ones that are closest to the nucleus and require the greatest amount of energy, our 1s electrons. Boom. Photoelectron spectroscopy practice done.